So we want the area bounded by cos t sine t as t runs between these values. So I find it helpful to sketch these things first. First we'll get a picture of what it looks like. If we plug in t equals 0, we wind up at 1, 0. Okay, if we plug in t is pi by 2, that'll get 0, 1. And if we plug in t is pi, we'll get negative 1, 0. Okay, so our direction of motion is this way. Okay, so the area that we care about is the stuff between this curve and the x-axis. Okay, so now let's substitute into our area formula. Put in our bounds. Now we put in the y-coordinate of our curve. And now we put d and then the x-coordinate of our curve. Okay. But this looks mighty strange. Right, we've got d of a function. Right, so what we have to do is we have to relate this back to dt somehow. Right, we want to make dt appear so that we can calculate an integral with respect to t. So we'll relate it back to dt. Well, this is the derivative of cos with respect to t. Right? This is the derivative in Leibniz notation. So we take the derivative and we get, this gives us negative sine t. Get something like this. Okay, and that allows us to replace this d cos t by something involving dt. And now this is a familiar kind of integral for us. So whenever we have d of a function, we're going to get the derivative of that function times dt. Okay, because we can do the same relationship through derivatives. Okay. Now, to integrate this, we have to do a little bit of trig wizardry. It's got to be using a double angle formula we can get here. Just a fact check. Is that the correct identity?
Yes.
Did I do that correct?
Okay.
Sometimes I put a plus here, and then everything blows up and it's terrible. Okay, great, so now we've used our double angle formula. Okay, here. But now this is something that we can integrate with standard techniques. Okay, so this half will turn into a half t. Our cos will turn into a minus four. Right, when we take the derivative of this, it'll produce a 2. That 2 will cancel. Okay. And now we can use fundamental theorem of calculus on this. So on one end we plug in pi, on the other end we plug in 0, and we get this equation. Okay, and doing the arithmetic, sine of 2 pi will be 0, sine of 0 will be 0. So we get negative a half pi. Very strange.